Alright, hi everyone, welcome to my YouTube channel City of Electrons, and in this video we're talking about power of signals. Of course, we've started working on past questions, so while working with the past question, of course we'll do explanation and then to get clarification of how to go on any question that looks like this particular past question. Okay, as long as the question is in this topic or under this topic, you can solve it. So let's just read the stuff and get the idea what we are asked to do in this question. So a zero mean sinusoidal message is applied to a transmitter that radiates an AM signal with 10 kilowatts power. Compute the carrier power if the modulation index is 0.6. What percentage of the total power is in the carrier? Calculate the power in each sideband. Given modulation index 0.6 and AM signal power PM 10 is by 3. Okay, how do I write that? See guys, let me just take that away. This thing we have here is the same thing as saying 10 times 10 raised to power 3 watts. You understand? Okay, so that's not 100, that is not 103, that's 10 raised to power 3. Okay, so let me just put this here. 1, 2, 3. Better. Okay, now, and that's what we have here. So now what we are asked to do, if you look at it carefully, you see compute the carrier power, which is this carrier power of the carrier C, and the next thing we have to do, calculate the power in each sideband. Okay, this I think I skipped something. Yeah, what percentage of the power, total power, is the carrier? That's this. Now a zero mean sinusoidal message is applied. Now, first thing to note, for zero mean, it simply means the center is at 0. So let's draw this to help ourselves see this thing better. Okay, so this is 0. Zero mean just sinusoidal, and you know sinusoidal is in this form. So the center of this is the highest point and the lowest point, positive, negative. So the center, the mean, is 0. Are we seeing it? That's just the simple meaning of a zero mean sinusoidal message. It's nothing complex. It just means that the center is at 0. The center of this wave of the what? The center of the sinusoidal wave is what? 0. That's the meaning of zero mean. Okay. So now for our data collection, the power. Now look at this carefully. Transmitted that radiates an AM amplitude modulation signal. AM amplitude modulation signal with 10 kilowatts. That's the power. Now so the total power, listen, the total power, okay, I've written that this is the total power required to send the signal. Okay, to transmit that signal, this is the total power required to transmit the signal. Okay, now the thing is this, we are now asked that we should compute the carrier power. But how do we get the carrier power? Now look at this total power. I should zoom in. Total power, I will just, to save time, I'll just do this. Total power. Okay, total power to transmit that signal, it will contain the power of the carrier signal and the power of the message signal. Okay, so how much power do you need to transmit the message? How much power do you need to transmit the carrier of the message? Everything together will give you a total power. Note that when we say message, power to transmit the message, okay, power of the message signal, this is the message you want to send from one radio station to another, or from one location to another. this is the power it requires to send that message. Now, in order to transmit this message from one place to another, we encode this message in a carrier signal. Okay, it's just like saying you want to travel from this point to this other point. Okay, you want to walk there. You want to reach that place. Now, instead of trekking, you can enter a bus. You can enter a bus that will take you there. Okay, so let's say this is the message. Okay, and you go into a bus. Now, inside the bus carries you. The bus carries you to your destination. This guy is the boss. Okay, now this may sound like a layman explanation, but I hope it gets the point across. So, in order to transmit a message, the message signal is encoded in the carrier signal. Okay, so when you encode the message signal in the amplitude of the carrier signal, is called amplitude modulation. Okay, so now this bus now, which is our carrier, this bus, if there is nothing inside the bus, this bus, of course you need fuel to carry it to 10 kilowatts. That's the power to move this guy. This is the bus. Now if you put the message inside, you will still, like, how much it takes you to fuel this bus to drive from here to here. Now if you put message, which is somebody inside, it will still take you the same amount of fuel. However, the fuel, or let's say the power, will be shared between the message and the carrier. So if there is no message inside, the carrier will take all the power. But if you increase the number of messages inside, add more message, add more people, what will happen? The power will be shared among the people and the bus itself. So the total power equals carrier power plus the message power. Are we seeing it now? Okay, so I think I should just shift this instead of erase it. So let's move this into somewhere else in case we need it later. Now we can just go ahead and start solving, but I just want us to see what's going on, have a mental picture of it, and know what we are doing exactly. So since we know that these guys are equal like this, okay, this, one thing to bear in mind before I go to do the next thing, one thing to bear in mind is that this is the amplitude, okay, amplitude, this is the amplitude, how high, okay, this is the amplitude. Now you can see that the amplitude is in two parts. This is the positive parts and then the negative parts. Okay, now the thing is this, the height, which is the amplitude for your carrier signal, okay, the height of that's the amplitude for your carrier signal, which is the bus. Then we also have the amplitude for your message signal. Now the ratio of the message signal, how the message signal affects the carrier signal, is known as modulation index. The ratio of amplitude signal to carrier signal is known as modulation index. That is what we have here, modulation index. Okay, so yeah, are we together? So I just want to point that one out. Modulation index, how the message signal, how the amplitude of the message affects the amplitude of the carrier. Okay, that's the modulation index. So I think I should write that one here. M equals what? AM over AC. So, but what is power like? What is power itself? Okay, so in this case, in terms of wave, power is just how hard the wave pushes. Okay, and we've seen this. So how hard? We can say that this one, the wave pushes harder in this case, and for this other case, the wave pushes harder. Okay, so we see that it has to do with the amplitude. Are we seeing it now? It has to do with the amplitude. So And note that for this, okay, this and then this, okay, the down is just so big, too big. Now the thing is that for the amplitude, you see you have a positive side and then negative side. So it's like when you double the amplitude, you will need what? 2 times the amplitude, so that will give you 4. Okay, you need 4 times the normal power you need. Okay, if you triple the amplitude, okay, because you are going 2 ways, you triple the amplitude, you will need 9 times power as much as for just 1 amplitude. So the power equals the amplitude, but note that we are going to square it, okay, because this will not affect if we double it, if we triple it, if we make it 4, this will not affect it like this. But in this case, just a unit, just 1. But just bear in mind that we say to calculate the power, we say the amplitude what? Squared. The amplitude squared. Okay, and of course we divide by 2, because this dividing by 2 will give us the average power from the positive side and then the negative side. So this is for power, calculating power. Now I think I should clean this part out. Now with that said, since this is for power, that means the power for the carrier signal, equals what? Amplitude of the carrier squared over 2. Are you seeing it? Then the power for the message will be what? Amplitude of the message over what? 2. But note that the message signal has the positive sideband and negative sideband. We'll take that into account for the message signal. It has a positive, but this is the message you want to send, not this message we are concerned about, not the carrier signal. So the message signal will have a positive sideband and a negative sideband. When I say positive, I mean like this: positive and negative. You know, the one we've been talking about since is this and this, but in the message we are talking about the positive and the negative sideband. Okay, so now in that case we have to divide this message signal by what? 2. Okay, which is the same thing as saying multiplied by 1 over 2. Okay, and this will now cause this guy to be what? Multiply them, so that will make them 4. So our message signal can be written as what? AM squared over what? 4. Okay, now with that, then we can say that the total power P total equals what? AC squared all over 2 plus AM squared all over what? 4. Remember, we have this relationship we have this relationship. Okay, we have that relationship. So we can just from this point do this: AC equals what? AM, just like you multiply this guy this way. Okay, so ACM, which is this ACM, equals what? M equals M. Okay, are we seeing what's happening? So in that formula, whenever you see AM, you plug in ACM. Okay, note that this C is subscript too. Okay, it's subscript. So let's do that quickly. So come here, and then this part now, AM, will put that ACM value. So that will now give us, oh boy, That will now give us PT equals AC over 2 plus ACL all what squared all over 4. Now from this point we can factorize. That is this. You see that there are things common here now. You have AC here, you have AC here. No, this one is squared. Okay, so let's quickly do that. Now if you remove AC over 2, AC squared, okay, what will be left here will just be 1 plus what? Now this part here, you remove this. As you factorize this 2, take it away from here, we remove everything from here and give us this guy. What's left is just 1. Okay, do the same to here. This 2 out, 2 divide this will give us 2 left now because we have taken 2 out. Alright, so that way that left, and what will be left inside? M squared, because AC squared has already been taken out. Are we seeing it? So that's what we have there. Good. So this will now serve as a formula for total power. Note that this thing here is exactly the same as what? It's exactly the same as PC. So we can come back here. And see what? And see P and say PT total power equals PC 1 plus M squared over 2, which we can now divide both sides by 1 plus M squared over 2. Okay, 1 plus M squared over 2. So this cancels this, and that will now give us what? PT total power 1 plus M squared over 2 equals what? PC. Okay, because we have to look for PC. So I can just even switch the sides, bring PC this way, Good. So at this point we just plug in our values. PT total power, that is this guy, so we put that value there. M, we have it, we put it there, and we're done with that first thing, which is this guy. We're done with that first one. So now if you can cram this formula you don't need to do all this many proving I just did. If you can cram this formula, okay, so this will now be what? Total power is 10 times 10 to the power 3 watts over what? 1 plus this guy is 0.6 power 2 all over 2, and this will now give you PC as what? 8.47. So this will now give you 8.47 times 10 to the power what? 3 watts. Okay, so this is the answer for the power it takes for the carrier signal. And the next question is percentage of the power of the carrier signal, and that's very straightforward. So percentage will be what? Let me do it this way. Percentage of this will be what? This over what? The total multiplied by 100. Simple as that. Okay, and that will be what? 8.47 times 10 to the power 3, and about this, that's equal to 84.7 watts. Okay, and then last one. So for the last one, the last part of this question is how much power do we have in each sideband? How much power do we have in each sideband? So already we have the formula that total power so already we have the formula that total power is what this for the carrier and then for the message. Remember that the message signal is made up of what? The two sidebands, which is the two sideband, let me say left and then right. So this will, so what you do, you calculate your power for message signal and then divide it by 2. That will be it. Okay, divided by 2. So that will be what? That will be your P total minus what? PC. That will give you PM. Okay, just like saying move this one this way and that kind of thing. So, and of course we already have, so PM will be what? P total, we have it as what? 10 times 10 to the power 3 minus PC, we have it as 8.47 times 10 to the power 3. Okay, so this will lead towards, so this will now give you 1.53 times 10 to the power 3 watts. So for each sideband, that will now give you power each sideband, anyhow you want to put it, each sideband. Okay, anyhow it will be PM divided by 2. So that will be what? 1.53 times 10 to the power 3 divided by 2. That will be what? That will give you 0.765 times 10 to the power. So that will give you power for each side as what? 0.76 times, or 60 me at the 5 there, 65 times 10 to the power what? 3 watts. So that'll be all. So that'll be all for this video. So comment, share, like, subscribe, and I'll see you in the next video. Thanks a lot for watching, and bye for now.